Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of line in R3. So as per the problem, a line passes through the points A and B. In part A, we have to write a vector equation for the line containing these points. So let's start with part A. We should write the general equation of a line in vector form. In this equation, vector r represents the position vector of an unknown point that lies on this line. Vector r0 represents the position vector of a known point that lies on this line. T is a parameter and it can be any real number. And vector m is the direction vector of the line. So for the position vector r0, we can use any of the two given points. So let's use point A. So vector r0 will be equal to the point A. Now we can find the direction vector of the line, and for that we should subtract the position vectors of the two given points. So we can do position vector of B minus position vector of A. We can also do it the other way, OA minus OB. We can use the given point B as position vector OB, and we can use given point A as position vector OA. Now we can subtract the position vectors by subtracting their x, y, and z components. 2 minus negative 1 is equal to 3. 5 minus 5 is equal to 0. Negative 4 minus negative 4 is equivalent to negative 4 plus 4, which is equal to 0. So this is the direction vector of the line. Now we can write the equation in vector form. So this should be the final answer for part A. Now we can answer part B. Write parametric equations corresponding to the vector equation. So we can rewrite the vector equation. Let's assume the position vector r represents the unknown point x, y, z on this line. Now we can break up this vector equation into parametric equations. So for the x equation, we should use the x components of the three vectors. And for the direction vector 3, 0, 0, we should multiply the components by t. So the x equation is now we can write the y equation using the y components. 0 times t is 0, so we can ignore that term. So the y equation is just y equals 5. Now we can write the z equation. So we'll use the z components of the three vectors. For the z equation, 0 times t is also equal to 0. So we can ignore that term. So the z equation is just z equals -4. So these are the parametric equations for the given line. So this should be the final answer for part B. Now we can answer part C. Explain why there are no symmetric equations for this line. So let's start by writing the general equation of a line in R3 in symmetric form. In this general equation, A, B, and C in the denominator represent the components of the direction vector of the line. And A, B, and C cannot be equal to 0 in this equation. Now the direction vector we found for this line is 3, 0, 0. So the y and the z components of the direction vector are equal to 0. That's why it is not possible to write the equation of this line in symmetric form. So we can write our answer as so this should be the final answer for part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.